Now the ith worker, that is the ith worker which we have. You're also given an array of bikes, so I also know that I have my bikes array. Now just as it's also says the location of that particular bikes array, which is xj comma yj. Now it is the all positions of workers and bikes. Now assign a bike to each worker. So basically I just need one worker to assign one bike. Among the availability of the bikes and the workers, we choose the worker bike, like worker of I, bike of j, as a pair with the shortest Manhattan distance. Now, like Manhattan distance, as they have just represented, is just nothing but absolute difference of their x and y coordinates respectively. So we want, firstly, the condition is we want to choose the worker bike pair such that they have the shortest Manhattan distance. So that is the condition number 1, which we need to make sure that is maintained. Other condition is if there are such multiple combinations of worker bikes. Now I will have to choose, okay, firstly is the shortest Manhattan distance. Next is we choose the pair with the smallest worker index. So second condition will be even if I got the same distance for two pairs, now I will choose the one having the smaller worker index, right? Now, okay, what if the worker index is also same? Now if there are multiple ways to do that also, then the third condition will be smallest bike index. So in this order of condition, I have to go about to choose which specific combination I have to take. Now we have to return the answer of length n, where for every worker I have to represent that which bike he should take, or basically which bike ID he should actually be taking. So that is what I have to return. Manhattan distance is what we have seen. So it's for sure that I know that for this worker I have the bike 0. So let's say that distance is d1. I know, and see this is the Manhattan distance, not the Euclidean distance, right? So I'll just say, okay, the distance is, let's say here d2. Now for this worker 0, again the distance is, let's say something which is d3, and for this again the distance is something, let's say d4. Now one thing you will see that this d2 and d3 are same, so I can just represent this as d2 itself, right? So now what I have to do, again my condition was if the distances is less. So firstly I have to get the minimum distance pair. So one thing you saw, I actually, before even thinking of, I tried to get, okay, for every worker what is the nearest distance to that bike. Now I will now choose this particular distance because it is the minimum distance out of all the distances which I have. Now which means I will have to firstly get all of these pairs, which means I have, let's say, n workers and m bikes. So I will have to get all the n cross m pairs for every worker bike combination. I will have to get this. Now when I will get this combination, I will just represent that with the distance. Now from what, which means from this worker of I, this is actually to a bike of j, because ultimately it is in the manner I will leave to grab this location, right? It is just this thing is actually represented by the distance between them, which is d1, the worker of I, which is worker 1, the bike of j, which is bike 0. Cool. Now firstly I just know one thing, that I will for sure grab this pair because it has a minimum distance. So I'll just grab this distance d1. I know, because for sure it's a minimum distance, I know that it's between worker 1 and the bike is 0. The bike is 0. Okay, I'll just grab this, and for sure neither the bike nor the worker has been taken before, so I can just easily grab this bike and this worker for sure. So I know that, okay, this bike and this worker is paired. Cool. Now I will have to go to the next small distance to actually bring up and make the pair. This distance is done. This distance is done. So let's remove this. Now next smallest distance is d2, but you saw d2 both are same, right? Now by the condition logic, we should actually take the smaller worker index. So d2 both are same, but this worker index is actually smaller. So what I will do is I will try to take this particular d2. I know it is worker 0 but bike of 0, but you will see here that the bike of 0 was already allotted to worker 1, so bike of 0 is no longer available. So for sure I cannot pair them up. Okay, cool. This is also gone, but I could not pair the bike, the worker 0 with bike 0. Cool, no worries. I just go on to my next possible thing, which is worker 1 bike 1, but with this you actually see that worker 1 was already paired with the smallest distance bike. So why to actually pair him again with a larger distance? So I'll also not pair worker 1. So you saw one thing, that okay, if any of the worker bike is taken, just to skip this one, and then ultimately I will have only last pair remaining, which is worker 0 to bike 1, which is actually a D4, worker 0 bike 1, worker 0 bike 1. I'll simply have to assign worker 0 bike 1 because that's a smallest possible combination which I could get. These were not possible, so it is a small possible combination. Now for sure I have to return the answer. For worker 0, I know the bike is bike 1, which is at index 1. For worker 1, the bike was at index 0. So I'll just simply keep on maintaining this answer, and you saw that this is the answer what I have to return, and that's the only thing. Now you saw that we kind of went on brute force way itself, which means firstly I made all these n cross m combinations, which means n workers and m bikes. I made all these combinations. Now when all these combinations are made, I know one thing for sure. Just simply when I say combinations, I actually made the combination like distance and then corresponding worker ID, corresponding bike ID. Now why this worker ID bike ID is needed? Because ultimately I will assign this worker with this bike for this distance. So I'll just keep on iterating on the smaller distance, right? So what I will do is I'll ultimately go and just have assigned these things, and I just simply have to sort it out then. But sorting again on the basis of what? Firstly on the basis of this distance, second on the basis of this worker ID, and then ultimately remaining on the basis of their bike ID. When this is sorted, now simply keep on iterating from start to end, and then just simply check, oh bro, have I already got either worker or a bike? Because if any one of them is actually used or basically allotted, if worker has allotted a bike, so simply skip it. If the bike is already allotted to some other worker, so also simply skip it. So in any of the ways I will have to skip my particular combination, else if not, then I will simply assign this particular worker to this particular bike. So this I will just simply assign it, and then I'll just keep on moving. So that will actually help me. Now with this, the complexity of the solution is n into m. Then you also know that n to m are the number of pairs, but then you also doing one thing, what? Sorting. So log of n into m. So that's the total time complexity of the solution. Now one thing you will see that it's actually okay. I can actually have a nm log nm as a time complexity. That is completely okay. But now one thing, another follow-up can come up as, can you improve this time complexity? Although that's a good one, you can actually work around with it, but can you improve this? Now if I want to improve this, then for sure the only possible way for me to actually improve it is kind of a n into logarithmic of n. So I can just make it a linear, which is the maximum I can do is n into m, because for sure I will have to go on to all pair combinations. But it is that maybe I can just reduce the log factor if I can with this. So whenever you have to optimize it, one thing is you can just work around with different data structure altogether, which means you can just try thinking of, let's say if I can just memorize something, but here it is not possible. Let's say if I can just do some pre-computation, which is also not possible here. The thing which actually lies in the end is actually look at the constraints. So you will see that actually why the sorting was required, because I wanted to sort on the basis of distance. But if you go and look back, distance is nothing but the Manhattan distance, which is actually the difference of x and y's. Difference of x and y, which means the maximum distance difference it can actually be a highest xi minus lowest xj, which means highest xi, which is 1000, and lowest xj, which is 0, and again highest yi minus highest low j, which is again 1000 minus 0. So maximum Manhattan distance difference can be 2000 at max. So what I can do is I can simply I know that the range of this distance is very small. So rather than making the entire pairs and then sorting it out, again I can just use a different concept. When this numbers are actually less, then a different sorting algorithm if I can use, which can actually optimize our answer. So that we will use a bucket sort. Now how bucket sort works is, let's quickly go on the same example which we discussed. Bucket sort will work like this, that as soon as I encounter any of the, I know firstly the bucket length can at max go to 2k, which is 2000. It is a maximum bucket length, right? Now in this bucket, I know firstly I will have to make all the pairs, but for every pair I will just simply go, I know, okay, it's a d1. So firstly I'll go at a d1, I'll go at a d1. Now in this d1 I'll place, okay, I have node with w1 b0. It is a specific in this particular distance, because or how this is useful, if you don't know bucket sort, then it is useful as in you will iterate from the start, because while you iterate from the start, you know that okay, it is the minimum distance, it is the minimum distance. Now okay, let's say if I get the d2, okay, if let's say here is a d2, I know that first I encountered a w0. Now Aryan, with this bucket sort thing, that is for sure you will maintain a smaller distance because you will go on from the left to right. But how will you maintain that thing that wi is less, like firstly you are actually working on wi and then you are working on bj? We'll actually figure that out, or we don't have to even figure that out. Why? Because if you know that if you iterate in a for loop, then in a for loop you will iterate from worker 0 to worker n, and then you will iterate from bike 0 to bike m. Now which means you are already, while iterating itself in the entire pair of our worker to bike, you are actually iterating in the order of worker to bike itself, which means worker are increasing in their smaller to higher, and bike are then increasing on their smaller to higher. So for sure, as you are iterating on the worker bike pair itself, you are actually iterating in this increasing order of worker bike, right? So for sure in d2 I will actually encounter and get first this bike, which is w0 bike 1. Then at the same distance, which means it's just a pair, at the same distance I am encountering another value, which is worker 1 bike 0. Now at a distance, let's say 4, I got a distance 4, I got a worker 0 bike 1. So you saw that this length, it can be at max of size m. Let's say it is 2000. Let's represent this as a x. This length is x. This entire thing, it again can be a n into m. But now you don't have to sort it, because you will simply know I can simply iterate from the very beginning. So I'll just go on to every block. So this is my block or a bucket. I go on to every bucket. Now on that bucket, I know that in accumulation I can have maximum of n into m, like these blocks, or you can say these pairs. So for sure the time complexity earlier was used because of sorting, but now it will actually reduce to, you will go on to every bucket which is x. Now ultimately for the ones who don't know this bucket sort or something like that, they might say okay, Aryan, it is x into this entire thing which is n into m. No, this thing in total will actually be in these x, right? So if I say everyone has one bucket, like for every bucket I have just one water cans. Like let's imagine this as water can, this one block as a water can, or like let's say it's a one block. So I can just say okay, if everyone has one block, so for sure x into 1 is actually nothing but the entire array, which is n into m, right? But you know x can maximum be 2k, so that can also point to 2k. But if everyone has two blocks, so for sure 2k into 2 is actually n into m. So you saw that buckets accumulation of blocks is actually n into m ultimately. So the time complexity will actually be x plus n into m. I saw and like I'll show you that in one of these cases the person has written that the complexity is x into n, but that is not correct. The complexity is actually x plus n into m. Cool. I hope that you guys got both of them approaches. Both of them are simply straightforward, just simply going on in the entire array, sorting it, and then simply iterating. It's just how you code, how clean code you write for this. So firstly we'll write this code, and then for as a follow-up question we will actually modify it to actually use buckets rather than simply sorting it out. Cool. Let's quickly jump on to the code itself. We actually reset this code. And again, we will try to write as clean code as possible. So what we can do in this is, we know one thing, that we have our workers. So I know that we have n workers. I also know that we have n bikes, right? We have n, sorry, dot size, we have n bikes. Now one thing for sure, that as I told you, I need to get a pair for this entire combination, which is distance. I'm just doing the version 1 as we saw, simply sorting the entire stuff out. So for that, I need to actually grab that node or block. So what I can do is, I can just name this as a block, or I can just name this as a node, anything whatsoever, whatsoever you want. Let's name it as a block, because that I can just simply use this block in the bucket sort also. I'll simply place that block in my bucket sort also. So I'll just name this as my all blocks, or name it as so it's just also like naming scheme works. But for this blocks, I'll also need to make, either you can make a struct or a class itself. I prefer class over a struct, but no worries, like anything you can do. Now for this block, you need a few things, which is distance. You also need a worker ID, because it is whatsoever you want to store, and you also need a biker ID. So as you can initialize this block also, so you, let's say you just got a few parameters, which is same parameters like worker ID and also the bike ID. So these parameters I can just assign. So let's assign the same parameters. It's just a constructor which is assigning these parameters to my, although you might say, Aryan, why didn't you take a vector of this? Again, firstly, it's not a good practice of taking vector, and for that vector, like in a code itself you can do it, but in an interview it's not a good practice to do it, and you will just try to see that vector takes more time rather than pair of pair. If you take a pair of pair, it will pass. If you take a vector, it will give a TLE, because the constraints are very edgy, right? So that's the reason. This node will actually take space only for that particular portion. Vector takes more space and more time, a little bit more, but that little bit can go a bit beyond. Cool. So what I will do is, now I'll simply, as I showed you, I'll just simply iterate on all of my workers. Now, although I can just name this indexing also as correct, but for now let's name it as INJ itself, because I know I am just going on my all the workers and all the bikers. Now for this specific I know that I'll just push back. Now firstly, before pushing back, I need to calculate the distance between Manhattan distance between these two workers and blocks. So I'll just say that it will be absolute difference as the Manhattan distance, workers of I minus workers of I, but that is because it's a coordinate, right? And then bikes of actually j and 0, and the same I can do it for the y coordinate of them, which is workers of I comma 1 minus bikes of j comma 1. So with that you will just get the distance. Now you know that you have to push back this particular node, but this particular node you have to make first, so which is for the distance. You know the worker ID, you know the corresponding block ID. Now I know that we have to sort our all blocks, so I'll just simply sort, because in the way when we are sorting all the blocks, right? So I'll just do sorting of all my blocks dot n. Now for sure, firstly it will try to sort on the basis of our workers, sorry, on the basis of distance, and then on the basis of our actually workers, and then on the basis of our that bikes. But still, if let's say if anything changes in future and you want to make your own comparator, then you can just use the custom comparator, although that won't be required because it sorts on the basis of left to right, so by default. But let's say in future, if you want to solve it, just for a side thing, that you can just make sure that you are actually putting in the correct values. So I just put in two nodes being compared. Now it's just a custom comparator which I am right now building. I'll just say if A's dot distance is not equals to B's dot distance, then for sure I can return that our A dot distance, it should actually be less than the B dot distance, which means sort on the lesser distance thing. But what if it's same? Then I'll just go and compare the worker ID. So if that worker ID is not same for both A and B, then I am again good to say that return A dot worker ID is less than B dot worker ID. Right now, when this is done, ultimately a case will remain that our worker IDs are actually different. Bike IDs are actually different. So I'll just say bike ID is actually less than B dot bike ID. Now when this portion is done, I know my entire thing is sorted, so I can just start iterating on my entire vector. But for that I also need my answer as a final. I can just simply put up default value of -1. Now why that is needed, you know that you have to keep track of what workers have been assigned a bike, and bike values are from 0 to m-1. So 0 can be a value, so I just put a by default value of workers assigned as -1, so that I can just easily check that if that worker has been assigned a bike or not. So I'll just go on to all of my entire of my this particular all blocks. So I'll just say all block in all blocks. Now for this every block which I'm going to, I know that I'm going in the increasing order of the distance, so for sure it's actually good. But I also need to make sure that my bikes are not visited, so I can just say that for this bike ID is that bike visited or not. So by default the value will be actually a false, so I can just have a check that or like I can just mention here itself that worker ID is actually all block, or like let's say simply a block, like because it's just a one block, right? Block, but block worker ID. So with this I can get a worker ID, and if I need a bike ID, I can just say block dot bike ID. Now when this is done, I have to firstly check if my answer of worker ID is equal to -1, which means that worker is not yet taken, and also my bike visited of this particular bike ID is actually also equal to false. If this is the case, which means both worker and bike are not taken, so firstly I'll just say that bike visited is of that particular bike ID is now true, which means lucky you have paired this particular worker and bike, and for sure this specific worker ID, I know that its corresponding bike ID is this one. Now ultimately I know that I have put in my entire answer, so I'll just simply return this answer. Let's quickly see if we don't have any compilation errors. It's not a biker ID, it's a bike ID, so that should be assigned biker. It's a bike ID, that is thing. Okay, it says that I cannot push back a block. It's a node. Okay, I have a block, right? So I should push in a block, and this is a node. Okay, also like what we saw in the beginning, we just did a mistake in that. Let's see if we have any other mistakes. Unordered. What's the spelling of unordered? I forgot. Unordered. Like, let me write it again. Unordered map. Oh, that's like some ease and stuff. Again, what's the issue in this? It just says answer of worker ID is equal to -1, and bike visited of this is equals to false. What's the issue in this? Visited of biker ID, bike ID, it's bike ID. You mean worker ID? Worker ID. Oh, I have put a worker ID here. It's a worker ID. Oh, okay, it's a worker. No worries. That's the reason, like, I just try to prefer pasting in the code rather than writing it down, but no worries. Now we have get this done. Now let's see that how we actually use those buckets. Now as you saw that we will actually have our bucket entirely made. So what we can do is we know that our bucket will actually be of size what? Firstly, it should be of size, let's name it as bucket. Now this bucket should be of size 2001. Now for this bucket of size 2001, I know one thing, that I can just keep on inserting my all pairs inside that bucket. So what I'll do is I know that bucket of that particular distance, because I'm just pushing on that particular distance, dot push back what this particular node itself, although you will see that this particular block I'm just pushing in, which is distance I and j, although you will see that the distance is not needed now, but I don't feel like changing my block. Or if you want, I can change my block also, but I don't think it would actually much be differing. So this portion of sorting would not be required anymore now I have my answer, I have my visited. Now rather than iterating on all the blocks, I have to iterate on the entire distance now. So I'll just go and iterate on the entire distance from this 0 to actually less than 2001. Now I plus plus. So this portion, this I is actually a distance. I is actually a distance, right? Now in this distance, I know that I have to iterate on all the blocks. Now comes the block part, that for auto block in actually the actually bucket, this bucket for this particular distance, I know that now I have to iterate on all of the blocks. And now I can just paste the same code here, that that it just goes on and find the worker ID for that particular block, find the this particular bike ID. If that is not visited, simply visit that, and just simply comment this out also. Now let's see if we have not done any mistakes. Again, vector, so these are typos which we should avoid. Now it just says that push back, okay, it's a block. Cool. So with this, you can easily see that is done. You will see the time complexity actually reduced by quite a lot, because we are not sorting it. Cool. Thank you so much for watching. See you in a little bit. Take care. Bye bye.